Hi everyone, how are you today? My name is Renty Cristo. Our topic for today is related inspection for transformer and also construction and testing. So thank you guys for viewing and thank you for your subscribing and please like. Okay, I will start. So the agenda of this presentations. So you try. We need to understand of the objectives and the principles and terminology, constructions, reference standards, typical inspections and test plan, and test details and related. So objectives, at the end of this presentations, you have clearly an idea how the electrical transformer works and how to proceed the inspections, as well as you learn the purpose of the test and standards procedures, typical acceptance criteria, typical mistakes, and instrument equipment needed. Okay. So work principle. What is the work principle? Transformer is an electrical device without continuously moving parts which transform energy from one more circuits to other circuits, as you can see and in this photo. So the power is transferred without electrical continuity between input and output circuit by using the principle of electromagnetic inductions. Mostly those who are studying electrical engineering, so all of you are familiar about these principles. And for those new, so this is the work principle. Electrical transform can be used typically for power transmission, electrical isolations between different circuits, measure of current and voltage. So the power rating of transformer is usually given in kVA, kilovolt ampere. Okay guys? So now our terminology. What is the terminology? Ambient temperature, the temperature of the surrounding atmosphere into which heat of the transformer is dissipated. Autotransformer. Transformers was part of the winding and common both primary and the secondary circuit. So boosting, as you can see, current transformer. What is the current transformer? Delta connection, that is D, and then distribution transformer. Those rated 5 to 120 kV of the high voltage side and formal use in secondary distribution system. So this is a part of our terminology. And there are so many terminologies. Okay. Now, next, exciting current, no load current. Current that flows in a winding used to excite the transformer when all other windings are open circuit. This is usually expressed in the percentage of rated current of a winding in which it is measured. So, example guys, FA. So, an ANSI calling class designations indicating a forced air ventilated transformer. So if you see this FA in a transformer, then you know already what is the meaning for that. Then fan cold. So cold mechanically to stay within rated temperature rise by addition of fans internally and externally. So FOA and then FOW. So an ANSI calling class designations. As you can see, all the terminology are there. Then another high voltage and low voltage winding. So it's very clear the terminations of the high voltage winding are usually identified if you are in the constructions, in the designs, especially you are in the constructions, you are the inspector. Some of you has always seen this in the actual terminations. Okay, UVW. So impedance, what is the impedance? And then insulating materials, insulations transformers. So this is the definitions. Okay. Then kVA. So that is meaning the voltage ampere output rating. So if you are talking about transformers, so transformers is always kVA. The voltage ampere output rating designs output that transformer can deliver for a specified time rated secondary voltage. As you can see here, 1 kVA. So meaning 1000 volt ampere. Okay. Next, so liquid immersed transformer. So what is the meaning of the liquid immersed transformer? And then load. What is the load? So meaning voltage, volt ampere supplied by the transformer. Loads are expressed as a functions of a current flowing in the transformer and not according to the watts consumed by the equipment and the transformer feeds. Okay, load losses, that is a load losses. As you can see, load losses transformer carrying load losses include I to R, loss of the windings. That's part of the calculations. Then kVA again. So the kVA voltage output rating designs. So liquid immersed transformer, load losses, no load losses. So in a transformer that excited rated voltage frequency that but which is not supplying load, no load losses include core loss, dielectric loss, and copper loss and winding due to exciting current. So OA, so OA mo naman, di ba? OA and ANSI calling designations. So potential voltage PT. So it's part of the instrument transformer. Instrument. Okay, a transformer used in the instrumentation circuit. Primary winding. Rating. Ratio test. A standard test of transformer used to determine the ratios of a primary and the secondary voltage. If you're attending pre-commissioning, testing, because during the testing, the vendor is there, and during your FAT, so you will be familiar if you are attending these kinds of testings. Okay, secondary winding, star delta, Y connection, step up transformer. What is the meaning of the step up transformer? A transformer in which the energy transfer is from the high voltage winding and the low voltage winding. That's why, for example, we have a transformer. So from 132 slash to 33 kV, or then 33 kV slash 6.6 kV, and then another 6.6 kV slash, okay, 400 volts or 0.433, 415. So this is the step down transformer. Then we have also step up transformer. Okay, step up transformers use energy transfer from the low voltage winding to high voltage winding. For example, uh, step up from 633 kV to 132 kV. So baliktad lang. So reverse. Okay. Now voltage ratio. The ratios RMS primary terminal voltage of the RMS secondary terminal voltage under specified conditions of the load. So temperature rise, total losses, turn ratio. Okay. So magnetic core. What is the magnetic core? Magnetic part of the transformer used to carry on the magnetic flux between different circuit. Loss requires a large core. So as you can see, the winding magnetic, as you can see in the below, that is our winding. So our wires that lays in the coils. So this is the familiarizations. If you are not familiar about this, so You need to study more about the transformer, and basically this is all about transformer, how it's work, what is inside of the transformer. That is all magnetic core winding. Okay, there's a single phase and a three phase connection. So we are here now in the constructions. So during the constructions, you install this kind of transformer. That is our oil filled transformer assemblies. Transformer with the oil conservator tank, as you can see there as in the photo. Then another one, oil filled transformer assembly. So that is fully sealed 11 kV step up to 33 kV high power transformer with cooling fins and oil conservator. Then this is our transformer again. Note the Buchholz relay mounted on the top of the main tank. So as you can see the Buchholz relays. So we have a lot of relays there. Okay. Then oil field transformer protections. Transformer requires protections in case of fault scenarios. They may be low oil level, overcurrent, over temperature, short circuit, earth fault, and over pressures. This is the transformer protections. So if something wrong with our transformer, either oil, either current, overcurrent, or temperature, or maybe short circuit, so this you can found that one that is part of the protections of the transformer. Sometimes there is an interview. The interviewer asks questions about how many protections in our transformer. So you can answer these kinds of information. So we have oil level, overcurrent, and then this is part of your interview as well. So basically, some of the technicians' positions, they're asking also these questions in the operator, works, technician, supervisor. Okay, so overpressure, this is the one. The instrument used to detect sudden overpressure is known as a Buchholz relay. So Buchholz relay and this device allow breathing while detecting sudden change. So the Buchholz relays relies on the fact that the electrical fault inside the transformer tank is accompanied by the generation of gas. If the fault is high enough, it will be accompanied by surge of oil from the tank to the conservator. So this is the oil transformer protection. Okay, now transformer get hot due to magnetizing of winding losses. So that's why we have a different uh, type of calling. So we have Onan, and then we have a Kinap. Different guys. You can check in the Google. So kinds of calling system, right? So this is the testing of the oil. The small sample of the oil must be taken and analyzed the first fill at regular intervals during maintenance procedure. So if you have a new transformer oil filled, so before we do energize and to run our transformer, so we need to test the first our oil. So is this okay or not? And then another testing again. So that is part of our commissioning procedure or SAT or OTP procedure. So